Good morning. My name is Aritish Rathod from the Department of CSE AI/ML Section C. Course title: Object-Oriented Programming. Today my topic is an overview of object-oriented design and C++. This is my topic and overview of object-oriented design and C++, and coming to the introduction to the object-oriented design and C++. Object-oriented design is a programming paradigm centered around objects and classes. C++ is a powerful programming language that supports object-oriented programming principles. This presentation provides an overview, key concepts and features of OOD and C++. And moving forward, what is object-oriented programming? Object-oriented programming organizes software design around data or objects rather than functions. The main principles of OOP include encapsulation, inheritance, polymorphism, and abstraction. Object-oriented programming helps in creating modular, reusable, and maintainable code. This is about object-oriented programming. And coming to the core concept of OOD. Encapsulation involves building data and methods that operate on the data within one unit or class. Inheritance allows new classes to derive properties and behaviors from existing classes. Polymorphism enables objects to be treated as instance of their parent class rather than actual class. This is about core concept of OOD. And coming to the benefits of object-oriented design. You can see the picture of advantages of object-oriented programming system, which is modularity, maintainability, flexibility, and reusability. Coming to its details, OOD promotes code reuse through inheritance and class inheritance. It enhances code maintainability by organizing related data and behavior together. OOD facilitates easier troubleshooting and further code enhancement. Coming to the introduction to C++. C++ is a multi-paradigm language that supports procedural, object-oriented, and generic programming. It was developed by Wijnand Stroustrup starting in the earlier 1980s. C++ is widely used for system software, game development, and real-time applications. And moving forward to the C++ syntax and structures, you can see the image of structure of C++ programming. Coming to its detailed C++ programs consist of functions, classes, and objects with the main function bring the entire point. Classes define the blueprint for objects, including attributes, data member, and behaviors methods. C++ uses header files, source files, and namespaces to organize code efficiently. You can see the structure about a header file and the main function and expression and declaration of variable and output and return statement. And coming to its classes and objects in C++. A class is a user-defined data type that encapsulates data and functions. An object is an instance of a class representing a specific entity in the programming. Classes enable the creation of multiple objects sharing the same structure and behavior. You can see the image of the classes and object how it looks like. Classes contain two types, private and public. Private is data member and public is member functions. And coming to the encapsulation in C++. Encapsulation resists direct access to some of an object's components, promoting data hiding. Access specifiers like private, protected, and public controls the visibility of class members. Proper encapsulation enhances security and reduces system complexity. Encapsulation in C++. This is the example of an image of encapsulation in C++. It consists of two, which is method and variables, as you see in the image. Coming to its inheritance and polymorphism in C++. Inheritance allows a class derived class to derived class to inherit properties and behaviors from another class, which is base class. Polymorphism in C++ is achieved through functions overloading and virtual functions. These features enable flexible and dynamic code behavior at runtime. You can see the image of inheritance and polymorphism. In inheritance, you find the variables, and in polymorphism you find the shapes, as shown in the figure. And coming to a abstract class and interface. Abstract class contains pure virtual functions and cannot be instructed directly. They define a construct for derived classes to implement specific behaviors. Interfaces in C++ are implemented using abstract class with only pure virtual functions. You can see the abstract class and interface image as shown in figure with abstract class shape, extend, cycle, and rectangle, where interface implements circle and rectangle. In abstract class we use extend, and in interface we use implement. Coming to its advantages of using C++ for OOD. C++ provides fine-grained control over system resources and memory management. It supports multiple inheritance, allowing complex classes inheritance. C++ has a rich library ecosystem and wide industry support for object-oriented development. You can see the advantages of OOD: probability, multi-paradigm, memory management, complexibility with C, and object-oriented, low-level manipulation, large community support, and scalability. These are the advantages. And coming to its common design patterns in C++. The singleton pattern ensures a class has only one instance and provides a global point of access. The factory pattern creates objects without exposing the instantiation logic. The observer's pattern establishes a one-to-many dependency between objects for event handling. You can see some patterns in C++, as shown in the figure. You can see the pattern print the number pyramid, and print the number diamond, and print the number vertical number pyramid. As we instruct the code, it will print the number diamond and in the number in pyramid, as shown in the figure. And there are many other patterns in C++. And coming to its best practices in OOD with C++. Use encapsulation to protect data and reduce system complexity. If you use encapsulation to protect data and reduce system complexity, prefer composition over inheritance to promote flexibility. Write clear, modular, and reusable code using solid principles. And coming to the challenges in object-oriented programming and C++, managing complex inheritance can lead to increased system complexity. For proper memory management is critical to prevent leaks and dangling pointers. Ensuring thread safety and adds additional complexity in multi-thread applications. These are the few challenges in object-oriented design and C++. Finally, coming to its conclusion and summary, object-oriented design improves software modularity, reusability, and maintainability. C++ is a versatile language that efficiently supports object-oriented programming features. Mastering OOD principle and C++ programming leads to robust and scalable software solutions. As you see in the image conclusion, object-oriented programming requires thinking about the structure of the program and planning at the beginning of the coding. Looks how to break up the requirements into simple reusable classes that can be used to blueprint in instance of objects. Overall, implementing OOP allows for better data structures and reusability, saving time into the run in the long run. Thank you for giving this opportunity.